lifting electrons in stages. Just like going down in height, you can go down a series of escalators. You can also increase it by a series of escalators. So, looking at this person going up heights 1 and heights 2, what would be a general formula you could create explaining their total height, h with a little t? Can you write a formula? If we do the same with voltage sources, that is batteries, easiest thing to see, and we stack two batteries, when the person goes up voltage 1, or in this case an electron, and then they go up voltage 2, what would be the total voltage they have reached when you add up the two voltages? Write a general formula, V total equals what? And you have an understanding of how sources in series go. Here would be two ways of connecting voltages one after another or next to each other. This one here would be like three escalators right next to each other. Each battery only lifts 1.5 volts, but there's no way for an electron to go in one and up the next and up the next. So this really just simply triples the electron supply available to this light bulb. But in this situation, each time the electrons go up into the next light bulb, they have ascended another 1.5 volts. This brings them up to a total of 4.5 volts. How many times have you seen devices take batteries one after another? When you do multiple batteries, you rarely see that they're lined up. They're inverted. How does that work? Well, if you look at the inversion, it's top, and you'll see the next one, it jumps over to the bottom. You can actually take this long stick and just roll it up. And I've got some pictures demonstrating that later, how most devices are using batteries in series. This is what we can imagine a series voltage supply looks like. Here's our Coulomb of electrons, Mr. Cool. You can see him at the bottom of the hill. He has very low energy, so he's kind of sad and droopy. Then he goes through the first battery. It lifts him up. He doesn't do the work to get up the hill. It does. So he's sort of fed like a high energy drink, and now he's at level 1. That will be 1.5 volts up. Then he climbs up another level or gets lifted up, and he's even higher. And then when he gets to the top level, he's at his maximum voltage here, 4.5 volts. This becomes sort of like the World Wrestling Federation, where the guy gets up really high and then he leaps on the other person who, for some inexplicable reason, doesn't get out of the way. So each battery is like a ladder. You're going up one and then the next and the next, and this gives you higher voltage. Almost always batteries are hooked up this way. We want more voltage. But they can be connected like this. This would be a parallel source. There are two ways up. So the two batteries would lift an identical number of electrons to a specific height. So this would be like two escalators that go up 10 meters. You don't get twice the height every time you add more escalators to this situation. You are simply increasing the traffic possibility, nothing more. Okay, so you either climb one after another in series, or they're next to each other. Next to each other increases traffic. Stacking them will increase your altitude. So this increases current. This situation increases voltage. Now we can see that in a common flashlight, this one will burn brighter because you've stacked 3. This one here should burn 3 times as long, providing everything about those two bulbs is the same. Now, instead of installing 3 double A's in parallel, why do you never really see this arrangement? Because if you actually just want more current, a longer lasting battery, then just go with a bigger one, a D cell. So they've already accomplished the current change by just telling you to go for a larger canteen of electrons, and then you stack them to get the voltage you need. And that's why they don't generally make 1.5, 3 volts, 4.5, 6 volts, 7.5 volt batteries. They go from 1.5 to 9 because you can get any voltage in between by stacking them. But the most important thing is when you stack the batteries, they must be the same chemistry and wouldn't hurt to keep them the same manufacturer, or weird things happen in reality. So that's why you're always finding situations where you take 3, 4, 5, 6 batteries and stack them in the appliance.